Hello, we're going to discuss a topic from Chapter 4, Section 6 today. So the topic that we are going to discuss is the permutation rule when we have some items that are identical. So the general setup for this problem is we want to determine the number of ways that we can arrange n objects when some of these objects are identical. So one thing with this type of problem is that we must use all of the objects that we have. We can't just use a portion of them as we did with previous permutation problems. So here's an example that we're going to walk through so we can understand the formula that we can use later on. So let's determine how many ways we can arrange the following colored circles, keeping them in a horizontal line. So the first thing that we need to do is we need to take away the identical nature of the identical objects by marking them. So we can mark these by number, by letter, by putting some dots on them. So in this case, I've decided to mark them with numbers. So the point of this is that we no longer have identical items. We can tell the difference between the different red circles and the different blue circles. So now we can determine the number of ways we can arrange these non-identical items as we're viewing them currently. So we know from our previous work with the fundamental rule for counting and the work that we've done with factorials that this is simply n factorial, the number of items that we have factorial. So we have 8 factorial, which is 40,320. So this number is too big since we know the circles were not originally numbered and that we did have identical items. So now we must make corrections. The corrections are made by looking at each set of identical items. So let's first look at just the red circles. So in order to make the correction, for having identical red circles, we must determine the number of ways we can arrange just the red circles. So we can use the same rule that we did on the previous slide, our factorial rule. So this would be the number of red circles factorial, or 4 factorial, which would give us 24. So we're going to have to use this 24 as a correction factor. So we can do this, make the same type of correction for having identical blue circles. So we look at just the blue circles, and then we would have the number of blue circles factorial. Once again, this happens to be 4 factorial, or the same 24. So now we can put all of our information together to find the true number of ways we can arrange these circles. To do this, we must divide by these correction factors, right? So we must divide by that number of red circles factorial and the number of blue circles factorial. So our formula would look like n factorial, right? Remember, n factorial was when we could distinguish between all of the circles. And then we must divide through by those 2 correction factors. So the number of red factorial times the number of blue factorial up here in the denominator. So this would give us 8 factorial divided by 4 factorial times 4 factorial, which reduces down to 70. So we would have 70 different ways that we can arrange these red and blue circles. So now let's look at the general formula. So the number of ways to arrange n items when some are identical is n factorial divided by n sub 1 factorial times n sub 2 factorial, so on and so forth until we get to the last item factorial, the number of the last item factorial. Right. So below we see the definition of what all these n's in n sub 1, 2, and so on and so forth are. Right. So instead of working through that entire process where we mark each identical item with some marking a number or a letter, we can just go directly to this formula, which streamlines the process. So let's use this process. So let's determine how many different numbers can we make by rearranging the digits in 1, 1, 2, 5, 1, 2, 7, 5, 0.15. So remember, we must use all of the digits. We can't just use 3 of them or 5 of them, so on and so forth. So the answer to this problem would be 10 factorial divided by 4 factorial times 2 factorial times 3 factorial times 1 factorial. So remember, 10 factorial is the total number of items that we have. So in this case, we have 10 digits in this string of digits. And then we move to the denominator. So 4 factorial is coming from the fact that we have 4 ones in this sequence of digits. And then I'm just going through numerically, so 2 factorial comes from the fact that we have 2 2's in this string of digits. 3 factorial comes from the fact that we have 3 5's. And then 1 factorial comes from the fact that we have 1 7. So then we can simplify this down, so we can evaluate the factorials and multiply and divide, which tells us that we have 12,600 different digits that can be formed, or different numbers that can be formed by rearranging these digits. So now let's give you a chance to work one of these problems before you attempt your homework. So the question for you is, how many words, I use the term words lightly because they're not actual words, but how many words can we make by rearranging the letters in addresses? So take a moment to work this problem, and while you're working the problem, please pause the video. So the answer to this problem would be 15,120. So we would have 9 factorial from the number of letters in addresses. 1 factorial comes from the fact that we have 1A, 2 factorial, we have 2 D's, 2 factorial again from the 2 E's, 1 factorial from 1 R, and 3 factorial from the 3 S's. So we can discuss this on Monday if you have any further questions. Thank you.